All right, today's lesson, more properties of exponents. But this time, we're dealing with division properties of exponents. So as you can see, we have fractions, but dealing with properties of exponents. All right, so the first property is called quotient of powers. So that simply means a division of powers. So just like the last video, we're going to do the full write it out process and then talk about what the property actually is. So the first example is x to the 10th divided by x to the 4th. All right, so the when in doubt, write it out process. On the numerator, x to the 10th, that means I have to write x 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X to the 4th means x 4 times. 1, 2, 3, 4. Now, I want you to think, what is x divided by x? X divided by x cancels out to 1. So you match up and cancel out your x's. All right, well, I have no more on the bottom, so I have crossed off all that I can. And then how many x's are left? So right here, 1, 2, 3, 4, 5, 6. X to the power of 6 is my solution. All right, second example, y to the 3rd divided by y to the 7th. All right, so y to the 3rd means y times y times y. And y to the 7th, I need 7 y's. 1, 2, 3, 4, 5, 6, 7. All right, match up, cross off. So this one is a little bit different. This time I've crossed off everything in my numerator, and technically what that means is I still have a 1 in my numerator, and then how much is left in my denominator. So that becomes 1 over 4y's y to the 4th. And for example 3, I have 5x to the 5th over 15x to the 8th. All right, so now I have coefficients and I have powers. So when I write it out, I still only have the 1, 5 and the 1, 15. And then x to the 5th, 1, 2, 3, 4, 5. X to the 8th, 1, 2, 3, 4, 5, 6, 7, 8. All right, so those coefficients, you treat it just like simplifying a fraction. So I can divide both of those by 5. So that becomes the fraction 1/3. And then match up, cross off. 1, 2, 3, 4, 5. I have 3 x's left over, so 1 over 3x to the 3rd. And as you can see, so I started with 10 and 4 and ended with a 6. Here I have 3 and 7, so I ended up with a 4, but it was in the denominator. And then 5 and 8, same thing, so I've got 3, and that ends up in the denominator. So as you can see, the solution is always the difference of my exponents. So it's like I'm subtracting. All right, so the rule to remember, if you have a power x to m, and you're dividing same base x, but to the power of n, you can do x to the power of m minus n. So you subtract your exponents. All right, now here are 3 examples using the property without writing it all out. All right, so 24x to the 14th over 6x to the 7th. All right, so just remember the difference between coefficients and powers. So 24 divided by 6, you just divide like any normal division. So that is 26 divided by 6 is 4. And then the properties of exponents tells you to do 14 minus 7. So that becomes x to the power of 7. And that's it. All right, next one, negative 2 x to the power of 2 over 16 x to the power of 12. All right, so you could think about this actually kind of a couple different ways. Well, first off, your coefficients, this time it's not a straight division. You have to think about simplifying that fraction. So that would simplify to negative 1 over 8. And then if you were to subtract your exponents, 2 minus 12. So two ways you can think about this is, well, 2 minus 12 is negative 10. So that would be x to the power of negative 10. But then because you have a negative exponent, you have to move it to the denominator and make it positive. So it becomes negative 1 over 8x to the power of 10. For me personally, instead of doing that step of like writing down negative 10, I just think, what is the difference between 2 and 12? And I know it's 10, and because there's more in the denominator, I know my answer will be left over in the denominator. All right, last example, a to the 13th, b to the 12th, c to the 11th, over a to the 16th, b to the 2nd, c to the 3rd. All right, so all we have to do, subtract our exponents. If you look at the powers with base a, 13 minus 16, that becomes a to the power of negative 3. And then base b, 12 minus 2, that is b to the power of 10. And then 11 minus 3, so that's c to the power of 8. And then deal with that negative exponent. You keep those up top, and that will send to the denominator to become positive. So b to the 10th, c to the 8th, over a to the 3rd is the final answer. Okay, here is the last property of exponents, power of a quotient. So this looks like x squared over 4. There's my quotient that I'm raising to a power. So the power on the outside tells you how many times to write what is inside parentheses. So that would be x squared over 4 times x squared over 4 times x squared over 4. And a reminder, when you multiply fractions, you just multiply straight across. So I kind of just turn this into one big fraction bar. So x squared, x times x, x times x, x times x. And then I have 4 times 4 times 4. So in the numerator, it becomes x to the power of 6, and then 4 times 4 times 4 is 64. All right, so next one, 3y to the 4th over 2 squared. This 2 tells me to write this twice. So 3y to the 4th over 2 times 3y to the 4th over 2. And then if I expand that over, remember you can multiply in any order, so I kind of group things together. 3 times 3 out in front, y to the 4th, 1, 2, 3, 4. Another y to the 4th, 1, 2, 3, 4. And then on the bottom, 2 times 2. So this becomes 9 y to the 8th over 4. All right, last one of these that we write it all out. The 3 on the outside, I'm going to write this 3 times. So a squared, b to the 3rd, c to the 4th. Boom. a squared, b to the third, c to the fourth. And one more, a squared, b to the third, c to the fourth. All right, so writing these out gets a little tedious, but I can write this all together here. All right, so, and I can group them together. So I've got a squared, and then another a squared, and another a squared. B to the third, 1, 2, 3, 1, 2, 3. Oh gosh, I'm going to run out of room. That's okay. We'll improvise here. And then on the bottom, c to the fourth, times c to the fourth, times c to the fourth, and that's it. All right, so total I have a to the power of 6, I have b to the power of 9, and then I have c to the power of 12. So what you can notice with all of this, similar to one of our multiplication properties, is this exponent on the outside kind of gets filtered in, distributed to everything on the inside. And then you apply the properties. That power to a power, we multiplied. So the rule to remember here is, if let's say I have a over x to the power of m, so there's my quotient, raising it to a power, I have to distribute, or just kind of filter through, sprinkle in to everything inside parentheses. So this becomes a to the power of n over, and then this is kind of just like that power to a power, so x to the m times n. All right, 3 examples using that property. First one, 7x to the 7th over y to the 3rd, raise that to the power of 3. So exponent on the outside, distributed through here. Now that coefficient, so that is 7 to the 3rd power, but then those double exponents multiply, so that becomes x to the power of 21, and then y to the 3rd is y to the 9th. I always want you to evaluate your coefficient all the way, so that will be 343 x to the power of 21 over y to the 9th. All right, so 3x to the 4th over 5 to the 5th. This 5, that will become 3 to the power of 5. X to the 4th to the 5th, multiply those exponents, so that becomes x to the 20th, divided by 5 to the 5th power. And then evaluate those coefficients, so 3 to the 5th power is 243, x to the 20th, and 5 to the 5th is 3,125. All right, last example. There's kind of a lot going on here. So a to the 3rd, b to the power of -2, c over a to the power of -1, b to the 5th, all raised to the power of -1. So if there are no coefficients in here, so it's basically -1 is being distributed to every exponent inside parentheses. So by multiplying all of those exponents, a to the power of -3, b to the power of +2, c to the power of -1 over -1 times -1, so that's a to the power of +1, b to the power of -5. All right, so one of the ways we can do this is now, because I have a and b, they have the same base, so I can subtract those exponents. So -3 minus 1, that is a to the power of -4. 2 minus -5 becomes b to the power of +7, and then I have c to the power of -1. Now b has a positive exponent, so that gets to stay, while the other two have to go to the denominator to become positive. So b to the 7th over a to the 4th and c to the 1st. And that is it. Those are all the properties of exponents involving division. Good luck with the lesson.